Okay. In the previous lecture, we were discussing about the basic terminologies of differential equation. We discussed that we can classify differential equations first into two major categories, ordinary differential equations and then partial differential equations. And then we started discussing ordinary differential equations. We can classify further ODEs by ordinary differential equations. In short, I'll write them ODEs. We can classify them with respect to their, for example, we discussed with respect to their order. We can classify ODEs with respect to their degree. And we can classify ODEs by their linearity property, or maybe linear, nonlinear ODEs. And another one, homogeneous and non-homogeneous. Sometimes homogeneous versus non-homogeneous ODEs. Okay. So these two we had discussed in the previous lecture, along with some other basic terminologies. Today we are going to discuss this one. Can we classify ODEs with respect to their linearity property? In fact, any general ODE of order n can be written as, for example, maybe let's start with the linear ODE of order n. Okay. A differential equation of the form a n of x dny by dx n plus a n minus 1 dn minus 1 y by dx dxn minus 1 plus so on plus a2 of x d square y by dx square plus a1 of x dy by dx plus a naught of x y equal to some function, maybe f of x only, where y is a function of x only, y is a dependent variable, and x is the independent variable. Okay. We also need some domain interval where this differential equation is defined. For example, we say that x belongs to some interval I, where I is a subset of R. So a differential equation of this form is basically nth order differential equation, and it is a linear differential equation. Okay. Its order is n. If we choose n is equal to maybe 2, if we choose n is equal to 2, then we'll get, of course, a second order ODE. For example, let's start with the 1. If we choose n is equal to 1, then what would be the ODE? A1 of x dy by dx plus a naught of x y is equal to some function f of x. So this is a linear ODE of order 1. Similarly, if we choose जी
सर, आपने x के सामने क्या लिखा है ऊपर रियल नंबर के साथ?
यहाँ पे
जी सर.
x belongs to I.
And I
is some interval.
Yes sir, thank you.
Okay? That is the domain. For example, you can say that I belongs to maybe a b interval, and this interval I call it I. So this is a first order linear ODE. The second, if we choose n is equal to 2, if we choose n is equal to 2, then what do we have? A2 of x d square y by dx square plus a1 of x dy by dx plus a naught of x y is equal to some function f of x. Okay. This linear differential equations of order 1 and 2, or even the nth order linear differential equation, they have certain properties which you need to know. There are two major properties. That the first one is the dependent variable y and all the first property or characteristics, maybe the dependent variable y and all its derivatives are of degree exactly equal to 1. Exactly equal to 1, maybe. Exactly equal to 1. That is, what does it mean? That is powers of y, powers of each term involving y is 1. This is a major characteristic of the linear differential equations. Okay. You can see that here in this whole term, in this complete term, the power of y is 1 here. Okay, the power of y is 1 here. In this term as well, the power of y is 1. And in this term as well, power of y is 1. Okay, we only see it on the left hand side. The right hand side could be a function which is independent of y. Okay, the right hand side function is the function of x only. Okay, so we see this characteristic only on the left hand side. Then this we call it linear differential equation. For example, if we have 2 here, maybe चलें पहले. We'll discuss the other possibilities later on. And one more thing which is important here, the second characteristic of this linear differential equation is that all the coefficients, these are the coefficients of the derivatives. Okay, the coefficients of derivative of y. This is, you can call it 0th derivative. The second thing is that the coefficients of these derivative terms, coefficients a of x, maybe you can say each coefficient, the coefficients of each term coefficient of each term is dependent only on x, which is the independent variable. Okay. So this is the coefficient here. Let me erase this thing. What are the coefficients? This is the coefficient. This is the coefficient function, in fact. A2 of x is some function. So here we say that this coefficient function is the function of x only. It should not belongs to, it should not involve y. Okay. Here again, this is a coefficient function. It could be x squared, sine x, cos x, anything. But this should be a function of x only. This again is some other function possibly it can be any function, but it should involve only x, independent variable. So this is all about the linear differential equations. Now, let me give you some of the examples of the linear differential equation, and you would help me to identify whether the given differential equation is linear or not. X dy by dx plus 9y is equal to maybe sine x. Is this differential equation linear? Anyone?
Yes, sir.
Okay, now tell me x maybe minus 2 y dy by dx plus 9y is equal to sine x. Is this differential equation linear?
No.
No, sir.
Why is it not?
Sir,
Because
क्योंकि
there's
dy by
y
dx
as a
में खोया है.
coefficient.
Yeah.
यहाँ पे आप देखें इस टर्म में y और y, it is basically arriving here 2 times. Here you have a power of y1, here you have power of y1. So in total, power of y is 2 in this term. Okay. In fact, in total, the power of y in this term is not equal to 1. Its degree is not 1. So this is not linear. Okay, not linear. So an ODE which is not linear, we call it non-linear, obviously. Okay, an ODE, an ODE which is not linear, we call it. You can say here, an ODE which is not linear is called non-linear ODE. So this is the other definition. Another example, maybe I can say that d square y by dx square plus sine x dy by dx plus e raised power x into sine y equal to 2. Now, can you tell me whether this differential equation is linear or not? Anyone?
No.
Sir, I think so. It is linear.
Okay, who is saying no?
Sir, I'm not sure, but it says that like we take out the derivative twice, so y must not be equals to 1 here.
No, the power of y is 1 here. There's no issue in this term. The degree of y is 1 here. The degree of y is again 1 here. Now tell me, in this term, do we have degree 1 of y?
Yes.
Yeah.
No, 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 no. कैसे होगी इसकी डिग्री 1? Sin x, is this a linear function?
कोएफिशिएंट y पे डिपेंड कर रहा है तो आई गेस नहीं होगी ना लीनियर.
Okay, so this is your sin y, or you can put some y here. Okay. So in this term, we have the degree 2 here. Okay. So this is not linear. But if we don't have y here, now can you tell me here what is sin y? Do you know what is the series of sin y, Taylor series? About x equal to 0? Do you know series? Have you already know Taylor series
सर
about?
ये टॉपिक नहीं पढ़ा अभी.
Okay, sine of something is not a linear function. Okay, so this is not, in fact, can be considered as y power 1. So this is not equal to this. Okay, you can say this. Sine y is not equal to sine y power 1. So this term is not linear. In this term, y, the degree of y is not equal to 1. Okay, this is not true. So that's why this differential equation is not linear. Okay. You should be sure that in each term, the degree of y should be 1. But
So
sine
if-
y, yeah,
Is this true for all trigonometric functions? मतलब cosine tan के लिए भी true है?
yes, any trigonometric functions. Even if you have e raised power y here, e raised power y, if you have e raised power y, even e raised power y is not equal to y power 1. Is this equal? No, this is not equal. So it is not linear. It is non-linear. Even if you have y here, for example, y and maybe 2y, and you have y here, sine y. So again, it is not linear because here you have some function of y. We don't know its degree, and still we have 1 here. When we add this and this, the degree of degree of y is no longer 1. So it is non-linear. I hope you get it. If you have any question, you can ask me.
So if we're taking the double derivative, then initially y ki power wouldn't be 1, right? So don't we consider that?
Can you repeat it?
If we're taking the double derivative, then initially y ki power would not be 1, so we won't consider that.
No, y is a function of f of x, for example, this one. If you take first derivative, nothing changes in y. The derivative changes only in the function of x. Okay, it becomes f dash of x. Okay, y remains same. Its degree remains same, 1. Okay,
Yeah.
you got my point?
Yeah.
Even if you take the second derivative, y would remain same. You are taking the derivative only on x, which becomes f double dash of x. You are not doing something with y. It's a dependent variable.
Okay, thank you.
Okay. So I hope you get the difference between linear and non-linear ODEs. In linear, this is you can say the explicit form of a linear nth order ODE. Other than this, if you have any products of y in a particular term, in one term, in this term or in any term, if you have the degree of 1 other than 1 in any term, that differential equation will no longer be a linear differential equation. Okay. So the products of y should not be involved. Products of y and its derivative should not be involved in any term. And transcendental functions means you can say transcendental functions kya hote hain calculus mein? I hope you know the exponential functions, trigonometric functions, log functions. They are all basically transcendental functions. We call them. Or if we have y power 2 here, if we don't have sine y here, and maybe x here, and we have y power 2 here. So in this term, we have degree of y 2. So it is still non-linear differential equation. So there should not be any products of y in one term or some other power of y in one term. So this is all about linear and non-linear differential equation. If you have any question, you can ask me.
So if we had e to the power y, फिर भी नहीं होगा, it won't be linear.
No, a to the power y, for example, a is some real number, 2 power y. So can you write 2 power y is equal to y? No. So 2 power y is not equal to y power 1. It is not linear according to the general definition of a linear nth order differential equation. Any other kind of function, transcendental functions, they involve also the exponential functions I told you. If there is some transcendental function in y, in terms of y, in any term of the differential equation, this differential equation will no longer be a linear differential equation. I hope you get it. Now, there are mostly I've written here first order linear ODE, this one, okay, and the second order. These are the most you can say example of. Let me say write the for n is equal to truth. We get the second order ODE, which I get a2 of x linear ODE d square y by dx square plus a1 of x dy by dx plus a naught of x and the y is equal to f of x. Okay. There are different notations for the derivatives. We can use them in order to simplify the notation. For example, d square y by dx square can be written as y double dash. Okay, you can write it in this way. Or d square y by dx square, it can be written as d square y. In fact, you know this thing, d square by आप पहले d by dx को लिखें, d by dx को अगर हम assume करें d and d square by dx square को हम assume करें d square and so on, dn by dxn को हम assume करें कि ये d power n है, then that differential equation can be written in the simplified notation as well in terms of d. For example, if we use this dash notation, okay, so then this differential equation can be written as a2 of x y double dash plus a1 of x y dash plus a naught of x y equal to f of x. Similarly, we can generalize this notation up to nth order. If we use this notation, we can write that general equation as a n of x dny plus so on plus a 1 of x dy plus a naught of x y equal to that function f of x. So there are different kind of notations which we can introduce in order to simplify or abbreviate the notation of the differential equations. These are just notations, just remember them. Now, if you have any question, you can ask me. Let me go to the other board. This cleaning stuff takes time. Okay. The next thing which we are basically interested in, solution of a differential equation. What is the solution of a differential equation? Solution of an ODE, because we are discussing ODE, but this works for any kind of differential equation. What is the solution of differential equation? Any function y, any function, you can see that any function, you can see that phi of x defined on some interval, defined on some interval I, because this is a function, which when substituted into a differential equation, the more general, this works for PDE as well, so that's why I've written here differential equation, not ODE. reduces the equation into an identity. Then we call it आप यहाँ पे ये comma लगा दें, is said to be a solution of the differential equation. Okay. Any function, in short, any function which satisfies that differential equation, that given differential equation, is called the solution of that differential equation. For example, if we have a differential equation dy by dx minus x y power 1 by 2 is equal to 0. Now, is this on the interval? Yeah, आप कह सकते हैं कि where x belongs to R. Okay. Now, this is the differential equation. Now, tell me whether this is linear or non-linear.
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 Okay. Yes. A function, we say that phi of x, and we say that it is x power 4 over 16. If we put this function here in this differential equation, you can call it y. Y is equal to phi of x. Okay. If we put the value of y here in this differential equation, does this equation reduce into identity? Now, what do we need here? In order to put this here, we need its first derivative, means for y dash. Y dash would be what? 4x cubed divided by 16. And it is what? X cubed by 4. You put this thing here on the left hand side, or you can consider left hand side. Left hand side is what? It is y dash minus xy 1 by 2, power 1 by 2. So y dash is x cubed by 4 negative x. The square root of y is a square root of y. Square root of y is what? It is basically x4 by 16. So you are taking its 1 by 2 power. Now, if we solve it, इस पे क्या आ जाएगा? X square over 16, x square into x cube. So these two terms are cancelled out. We get 0, and it is the right hand side. So this equation has been reduced into identity. This side is 0 and this side is 0. If we insert this function into this equation, so this is, we call it a solution of this differential equation. I hope you get it. If you have any question, you can ask me. Let me give you. जी जी.
इस ये जो आपने बनाई है इक्वेशन, ये सिर्फ फर्स्ट ऑर्डर के लिए?
ये इक्वेशन फर्स्ट ऑर्डर है. It doesn't matter कि इक्वेशन का फर्स्ट ऑर्डर क्या है. Any function which reduces the given differential equation into identity, that is called the solution of that differential equation. For example, आप एक और एग्जांपल ले लें. एग्जांपल जिसमें आपके पास ऑर्डर 1 नहीं, ऑर्डर 2 है. फॉर एग्जांपल द डिफरेंशियल इक्वेशन इज y डबल डैश minus 2y dash plus y equal to 0 on minus infinity to infinity. Means x belongs to this interval. Now, we have to show that y is equal to x e raised power x is the solution of given differential equation or given ODE. How do we do this? We take, we insert y here. So in order to insert y here, we need 2 derivatives and then 1 derivative. So we take it first derivative, x as it e raised power x का derivative. जी 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 जी.
सर हमने पिछला जो सवाल किया जिसमें हमने प्रूव किया कि ये 0 है, which is equal to 0 right hand side, even though इक्वेशन लीनियर नहीं थी तो इसका मतलब ये फिर भी सॉल्व हो सकती है चाहे इक्वेशन लीनियर हो ना हो.
Yeah, that depends. ठीक है, first order nonlinear equations can be solved. Linear as well as
अच्छा, लेकिन
non-linear. We can solve them. ठीक है. Hey,
Okay.
we'll discuss some of the methods how to solve differential equations. Still, we haven't discussed how to solve differential equations and what are their methods to solve them.
Okay, sir. Thank
So
you.
this is the first derivative, and the second derivative is x e raised power x plus 1 times e raised power x plus e raised power x. Okay, so we are applying here, in fact, the product rule. So what is the second derivative? It is x plus e raised power x2. So x plus 2 e raised power x आ जाएगी. ठीक है, और यहाँ पे x dash जो है x plus 1 e raised power x. ये first derivative है, ये second derivative है. Now you put these things here. You must get, after simplification, you consider the left hand side of that differential equation is y double dash minus 2y dash plus y. Now you put y double dash, which is x e raised power x plus 2 e raised power x minus 2 times y dash is what? Y dash is this thing, and minus 2 times is x e raised power x minus minus 2 e raised power x minus 2 e raised power x plus y. What is y? X e raised power x. Okay. You can see that here we have 1, 1. It is 2x e raised power x. If we add up these two, and we have negative 2 e raised power x. This term will be cancelled with these two, and this term will be cancelled with this. So we get 0, which is the right hand side. So what we concluded here, that this function is the solution to this differential equation. Okay, this is y is equal to phi of x. Phi of x is some function. What is that function? E raised power x, x into e raised power x. So if we substitute this thing here in this, the left hand side of this differential equation, after finding the respective derivatives, we get 0, which is the right hand side. So we can say that this is the solution of that differential equation. I hope you get it. If you have any question, you can ask me. There are few types of solutions of the differential equation. For example, explicit solution of a differential equation and then implicit solution of a differential equation. Explicit solution is basically the explicit function. I hope you know what is the explicit function. If an explicit function satisfies that differential equation, then it is called explicit solution. What is explicit function? Explicit function is a function which can be written in this form: y is equal to f of x. Okay. Here you have the degree of y is 1. Y in terms of f of x. If you can write any solution in this form, then it is called explicit solution of that differential equation. Okay. If you cannot
Can you please
write,
explain this again?
y is an explicit function of x only. Okay. For example, you say that y is maybe x, जैसे अभी हमने ऊपर लिखा x into a raised power x. This is the function of x only, and we have y here whose degree is 1. So this kind of function is called, which can be written as y power 1 is equal to f of x. This is called explicit function. Okay. In which y can be expressed explicitly as a function of x. Okay. If the solution is an explicit function, then we call it explicit solution. Otherwise, it is possible that a solution of the differential equation is not an explicit function. Then in general, we write it in this form: g of xy equal to 0. Okay. Because that solution cannot be expressed in this form. Then we in general, we write it in this form, g of xy, and this is called an implicit function. Implicit function of x and y. X and y. An example of this thing is, maybe you can say that x square y plus xy square. Can you separate y from this function? Anyone who asked me that question, explicit? Can you separate y from that thing?
No, sir.
Okay, this is an implicit function of x and y. So this kind of solution is called implicit solution of the given differential equation. Okay? Or even you can say that x square plus y square is equal to 0 even. We cannot write explicitly y in terms of x in this function because it's a circle and it involves plus minus or radical square root of something, and we cannot write y in terms of x explicitly. Next is one parameter family of solutions or n parameter family of solutions of the differential equation. I hope you get it. If you have any question, you can ask me. Let me erase this thing. Okay, if we write a first order ODE, whether it is linear or non-linear, we don't need to worry about it. If we have a first order ODE, let me give you the notation, general notation of first order. That particular notation which I have written previously is basically a linear nth order ODE, linear nth order ODE. If we have some non-linear first order ODE, how do we write first order ODEs in general form? First order ODEs. How can we write them in general form? Generally, we can write first order ODEs in this form. It is some function of x, y, and y dash is equal to 0. For example, that equation which we have written previously for as an example 1, in order to verify the solution, what was that differential equation? dy by dx minus xy power 1 by 2. Okay, this is equal to 0. Now, this left-hand side, can I write that this left-hand side is a function of x because it involves x? This is always the independent variable. You write here. Okay, and it involves y variable, and then it involves y dash. So I can write this whole differential equation, first order differential equation, in this form more generally. Okay, this is your independent variable and this is your dependent variable. Okay, it is dependent variable, and this is the first derivative of dependent variable, because in first order ODEs, you can only have independent variable, dependent variable, and its first derivative. That's why we call it first order ODE. Okay, whether it is linear or non-linear. So the general notation of the first order ODEs is this. And general notation of second order ODE, how can we write it? It's obvious from this kind of notation that we can write that thing f of x, y, y dash, and y double dash. So in general, second order ODE involves independent variable, dependent variable is first derivative and second derivative. Okay, so this is the general notation of ODE of order 2. And nth order ODE, its general notation would be f of x, y, y dash, y double dash, and so on. How many derivatives? N derivatives equal to 0. So this is the general notation of nth order ODE. I hope you get it. If you have any question, you can ask me. Now, what was
Sir, I
I
have a
going
question.
to? Ji beta.
Sir, why are they equal to 0?
They need not to be 0, but in that differential equation, for example, even if you have a non-zero variable or function here, tell me what should I write here? E raised power x, for example. We can write this differential equation minus e raised power is equal to 0. So it is still the same function f of x, y, y double dash equal to 0. So we have to make it general. So we don't consider some particular function here on the right hand side. So we can bring that on the left hand side and we still can denote that differential equation in the same way. I hope you get it.
Thank you. Thank you.
सर अगर वो
Okay.
इक्वल टू वाई स्क्वायर होता तो हम भी ऐसे ही लिखते जैसे ये लिखा
Equal to क्या होता?
वाई स्क्वायर, जैसे जो आपने ई पावर एक्स को इक्वेट किया,
हाँ।
अगर वहां पे
यहाँ पे वाई स्क्वायर है फॉर एग्जाम्पल, आप ही कह रहे हो, ठीक है। अब वाई स्क्वायर को उधर ले आओ यार, वाई स्क्वायर को उधर लाएंगे अगर माइनस वाई स्क्वायर इक्वल टू 0 नहीं कर सकते हम। इट इज स्टिल द फंक्शन ऑफ एक्स वाई एंड वाई डैश. No new variable has been involved or introduced in that thing. So it is still function of x, y, and y dash because it is a first order differential equation. It cannot involve something new other than x, y, and y dash. So in general, it is a function of x, y, and y dash. So the notation would remain same in any case for the first order differential equation. I hope you get it. Any further questions? No? Okay, let me then define one parameter family of solutions. Family of solutions. देखिए, अगर हमारे पास फर्स्ट ऑर्डर ओडी है, उसमें कितने डेरिवेटिव इन्वॉल्व हैं? एक डेरिवेटिव फर्स्ट ऑर्डर डेरिवेटिव है, ठीक है। अब किसी भी इक्वेशन में से डेरिवेटिव को रिवर्स करना है हमने in order to find the solution, because solution is basically has a form y is equal to some f of x or phi of x. So we need to eliminate that derivative from that equation if we have a first order differential equation while solving it. How can we eliminate that derivative from that equation? Anyone? Do you have any idea? If we have dy by dx, how to get y from this thing? What do we do?
Sir, integration.
Yes, we have to apply integration here in order to reverse that derivative into some function. Okay. If you want to solve that differential equation of first order, you must have to apply integration at least once. Okay. Or you can say exactly once. अब फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन को सॉल्व करने के लिए, क्योंकि उसमें एक डेरिवेटिव है, डेरिवेटिव को रिवर्स करना है, आपने y फाइंड करना है। रिवर्स करने के लिए आपको इंटीग्रेशन करनी पड़ेगी एक टाइम, ठीक है। अब आपने इंटीग्रेशन कर ली, जैसे कि वो डिफरेंशियल इक्वेशन है dy by dx माइनस एक्स वाई 1/2 इज इक्वल टू 0, ठीक है। अब आपने क्या करना है, इस पे by using some kind of technique you have to apply integration first, and then you have to apply some different techniques in order to solve that integral term. After solving that integral term, what do you get? What do you expect? you expect some function y in terms of x. Either this one, if you are lucky enough that you get an explicit function as a solution, but we are taking more general implicit solution. I call it g of x, y. After integration, this differential equation, I get some function g of x, y, which is implicit solution of that differential equation, which involves x and y. Now, one more thing which is important here, while integration, what we do generally, if we are doing indefinite integrals, if we integrate some function, do we have to add something extra in that?
Yes, plus C, sir.
Plus C. So we normally, while doing integration, we add some constant after integrating a function. And that constant is called constant of integration. यही है ना? तो हमारे पास क्या आएगा? सिर्फ after integrating this, we do not get only the function of x and y. We get a function of x and y and a constant c in that function. Okay, after integrating that equation one time, we must get a constant c in that expression, which we obtain in terms of x and y, and we have to add some constant in that. So this will be the solution of this differential equation, which involves one parameter. So that is why we call it one parameter family of solutions, where this C belongs to R. If we change the value of C, we get another solution. Okay? For different values of C, we get different solutions. So it's basically a family of solutions which involves one parameter. So that is what we call it, one parameter family of solutions. And we write it in this form, g of x, y, comma, c is equal to 0. The similar concept can be applied here on the second order differential equations. If we try to solve some second order differential equation, it obviously involves second derivative of a function. Okay? And while solving it, we have to find y, an implicit or explicit function which involves only x and y. So in order to reverse those two derivatives, you have to take two integrations. 2 times you have to integrate that equation 2 times. When you integrate that equation 1 time, you get one constant, and when you integrate that equation second time, you get another constant. So in total, you must get 2 constants in that solution kind of thing, which is implicit or explicit solution. So in this case, if we have a second order differential equation, I call it that we obtain a function, I call it g1 maybe, and we call it g2. A function g of x, y, after integrating this equation, second order differential equation 2 times, we get a function which involves x and y plus 2 parameters, c1 and c2. Okay, and we put it equal to 0. So this is called what? 2 parameter family of solution. Okay, 2 parameters.
Excuse me, sir.
जी.
Sir, C यहाँ पे constant है.
It's a parameter, not constant.
So can you please?
Not a fixed constant. Huh?
Sir, can you please explain ये parameter यहाँ पे आया कैसे?
आया कैसे नहीं, हमने लिखा है, आया नहीं है अभी. मसलन आपके पास ये एक डिफरेंशियल इक्वेशन है. फॉर एग्जांपल, आई एम गोइंग टू राइट इट वेरी सिंपल. dy by dx is equal to maybe x. ठीक है, is this a differential equation? I'm going to integrate it both sides. dy by dx respect to x and integral x respect to x. ठीक है, अब इसको इंटीग्रेट करेंगे तो डेरिवेटिव इंटीग्रल क्या हो जाएगा? कैंसिल होगा. So what do we get here? Y is equal to, here what do you get? X square by 2 plus क्या लिखते हैं?
C लिखते हैं सर.
C. ठीक है? Now, what is this C? This is, we call it constant of integration, but this constant is arbitrary constant. It can be any constant. ठीक है? अगर आप इसका दोबारा डेरिवेटिव लें तो क्या आना चाहिए आपके पास? x आना चाहिए ना? अगर आप दोबारा डेरिवेटिव लें तो यहाँ पे क्या आएगा? dy by dx is equal to what? 2 times x divided by 2 plus constant का डेरिवेटिव 0. You get again dy by dx is equal to x. But आप ये देखें कि ये कांस्टेंट अगर फर्ज करें मैं यहाँ पे लिखता हूँ कि ये कांस्टेंट ओरिजिनली 1 था, ये फिर भी 0 हो गया. मैं कहता हूँ ओरिजिनली ये 2 है, फिर भी 0 है. ओरिजिनली ये 5 है, फिर भी 0 है. So any constant will become 0 while taking the derivative of this function. So this is an arbitrary constant. It can take any value. So that is why I told you there that if we have a one parameter family of solution, which we write in terms of G1 of X, Y, C, then C is some parameter which belongs to real number. Okay? So how many real numbers are there? It's not a fixed constant, it's a parameter. Parameter is a constant which can take different values. Okay? So that is why we call it one parameter family of solution. जी जी जी.
सर जब हम लोग 2 दफा इंटीग्रेट कर रहे होते थे तो अक्सर ये होता था कि जब आप कांस्टेंट ऐड करते थे पहली इंटीग्रेशन में तो दूसरी इंटीग्रेशन में दोबारा से कांस्टेंट नहीं ऐड करते थे क्योंकि आर्बिट्रेरी है तो फिर वो ऐड अप ही हो जाता था. तो इट डिडंट मैटर 2 दफा ऐड करोगे एक दफा.
Technically you have to add 2 times. There might be some particular situations in which the constant may be updated in the second integration, but it is not the general case. Okay. In general, you have to add 2 constants. Okay. So that is why we call it 2 parameter family of solution if while solving the second order differential equation. In general, whether the equation is linear or non-linear, we don't have to do with that thing. We are talking about the solutions, possibilities of solutions, and they involve constants. If we try to solve nth order ODE, we have to take n times integrations, and this will involve n parameters, so that the solution of this kind of nth order differential equation will be n parameter family of solutions. I hope you get it. All these details are given in my lecture slides and notes. You can read from there. If you have any question, you can ask me.
Sir, I have a question.
Excuse me, sir. I have a question. Okay.
जी बेटा.
Go ahead.
सर आई जस्ट वांटेड टू आस्क कि सर जब हम इंटीग्रेशन करेंगे जो जैसे सेकंड ऑर्डर डिफरेंशियल है सर जो पहला कांस्टेंट है वो तो फॉर एग्जांपल अगर हम विद रिस्पेक्ट टू x कर रहे हैं तो x में कन्वर्ट हो जाएगा. सही है? तो
क्यों
सर
कन्वर्ट हो जाएगा? क्यों कन्वर्ट हो जाएगा x में?
नहीं सर जब दूसरी दफा इंटीग्रेशन करेंगे जो तो कांस्टेंट है उसके साथ x लग जाएगा ना.
हाँ.
तो कांस्टेंट सिर्फ एक नहीं होना चाहिए.
तो फिर एक नया कांस्टेंट ऐड नहीं करेंगे? मसलन यही आपके पास एक मैं आपको फंक्शन देता हूं कि सेकंड डेरिवेटिव है आपके पास d square y by dx square is equal to, maybe you tell me, what should I write here?
E power x.
Okay, e raised power x. Now you integrate one time, what do you get here? Dy by dx, an integral of this thing e raised power x plus c1. This is your first constant after applying integration one time. Now you apply the second time, you get y is equal to e raised power x plus c1x, क्योंकि c constant c1 है, इस 1 का इंटीग्रल होगा, यहाँ पे 1 का इंटीग्रल आपके पास x आ जाएगा. Now you have to add another constant here, which is the constant of integration here. हो गए 2 constant?
Okay,
होंगे ना?
समझ आ गया सर. थैंक यू.
सेकंड कांस्टेंट तो कोएफिशिएंट है x का. इट्स नॉट अ सेपरेट वो तो कोएफिशिएंट है x का. तो जब हम लिख रहे होते हैं ब्रैकेट के अंदर हम तो सिर्फ वो लिखते हैं जो न्यू टर्म्स हैं. दिस इज ये x और y.
You got it or not? Do you have any question? Who is this talking? Mariam?
No, sir, I didn't get it. मैं बोल रही हूँ कि it's a वो coefficient of x now, the c1, so why do we write it separately inside the bracket?
कहाँ पे?
So जब आपने लिखा था g2 लिखा था तो उसमें
Now,
आपने
if you want to write this function in general, we put it equal to 0 by putting minus here. What would you write here? What is this thing a function of?
y x and c2
Huh?
y x and c2
C1 क्यों नहीं?
so तो coefficient है x का.
This is unknown constant. This is important. We don't know it.
No.
Do you know this? What is the value of C1 here?
No.
No, it is important constant. C2, do you know its value? No. So it is important constant. So as a whole, this is a function of what? There are 4 unknown things here. X, Y, C1, C2. है या नहीं?
है.
So इसको हम क्या लिखेंगे in general? This is a function of some X, Y, C1 and C2. We put it equal to 0. So this is your 2-parameter family of solution.
अच्छा ठीक है, thank you.
ठीक है?
So we write all the unknowns, right?
Yes.
ठीक.
Later on, we'll discuss how to find these constants. We have to, we cannot leave them unknown, these parameters. It depends on the physical phenomena. We have to add some additional conditions in that physical phenomena in order to find the values, the particular values of these constants. For example, I told you in the previous lecture, कौन सा लॉ करवाया था मैंने आपको? कॉफी वाला, चाय कॉफी?
Law of cooling.
हाँ, कूलिंग लॉ, न्यूटन्स कूलिंग लॉ. न्यूटन्स कूलिंग लॉ में हमने प्रीवियस लेक्चर में क्या पढ़ा था? कूलिंग लॉ. हमने एक डिफरेंशियल इक्वेशन डिराइव की थी, dt by dt, which is proportional to, if we remove that sign of proportionality, we say that t minus t naught. ये किया था. और मैंने साथ में एक इनिशियल कंडीशन आपको दी थी. इनिशियल कंडीशन, ठीक है? इनिशियल कंडीशन was what? The initial temperature at time 0 of that coffee is what? 100 degree. This is the extra condition which help us to find that arbitrary constant involved in the solution of first order differential equation. Okay. So this is the additional condition which we require in order to find that one parameter which is unknown in the solution of first order differential equation. One parameter family of solutions. ये आपके पास first order differential equation है, ठीक है? This one is a first order differential equation. We have to solve it. After solving it, we'll get one parameter, one unknown parameter, which is the constant of integration. After integrating this equation, we must get one constant of integration, which is the parameter in that solution. We call it one parameter family of solution. In order to find the value of particular value of that constant, we have to use this initial condition. So that's why we need additional conditions in order to find those constants. If there is one constant in the solution, then we need one condition. If there are two parameters in the solution, means if we have second order differential equation, its solution will be two parameter family of solution. So we must have two conditions in order to obtain the values of two constants. Parameters, in fact. I hope you get it. If you have any question, you can ask me. You got my point?
Yeah.
Again, I assume that its solution is some kind of t of t is equal to maybe some constant c1 e raised power maybe minus t. Okay, I'm assuming this is not the solution of this thing. T minus maybe t naught. यहाँ पे कर लें. I'm not sure about it. Yes, it's a kind of this thing. The solution will be of this kind. Plus है यहाँ पे, तो plus आएगा t minus t naught. इस तरह का solution होगा. अब देखिए यहाँ पे कांस्टेंट है, पैरामीटर है, इसको फाइंड करना है हमने. You have to solve, you have to use this condition. ये condition क्या है? When t is 0, capital T is 100. Okay. Now put these values in this solution. What do you get? T of t is 100, T of 0 is 100, and C1 e raised power maybe थोड़ा सा simplify कर ले इसको, e raised power t रहने दो, थोड़ा सा आसान हो जाएगा. So C1 e raised power t is what? 0. So e raised power 0 is 1. What do you get? The value of C1 is 100. So this condition helps us to find the particular value of that parameter. So along with the differential equations, we need some extra conditions. These conditions can be defined by observing the physical phenomena. Mostly, we define these kind of conditions at initial time. जैसे कि हमने हमने कहा था कि जब हमने उसको स्टोव से उतारा, कप में डाला, तो initially we assume that its temperature, it can be measured in fact by using some thermometers. The initial temperature हमने कहा कि चाय का ये है. हमने assume किया कि जो ही हमने चाय कप में डाली तो उसका 100 डिग्री टेम्परेचर है. So this is an observation on physical phenomena. So this is a condition on initial time. That is why we call it initial condition. So these kind of conditions, they help us in finding those unknown parameters involved in the solutions of differential equation. And as a whole, this problem is called initial value problem. Okay, and this problem is called initial value problem. Okay, because along with the differential equation, we have one initial condition. The differential equation along with the initial condition is called initial value problem. If it is the first order differential equation, we must have one initial condition. If we have second order differential equation, we must have two initial conditions in order to find two unknown parameters in the differential equation. Okay. And I hope you get it. If you have any question, you can ask me. Now, do you have some question? Okay, then that's good. Let me know. There is another kind of solution which is called particular solution. Particular and then singular solution and singular solution of a differential equation. Okay. Particular solution is a solution which can be obtained by taking some particular value of the constant parameter in that one parameter family of solutions or parameter family of solutions. For example, अगर आपके पास देखें, let me explain this thing to you with the help of an example. यहाँ पे ठीक है, हमने एक डिफरेंशियल इक्वेशन डिस्कस की थी, y डैश इज इक्वल टू x y 1/2 या x माइनस x y पावर 1/2 इज इक्वल टू 0। हमने अस्यूम किया था कि इसका सोल्यूशन क्या है, x2 over 4। This is the solution, but this is a particular solution. It doesn't involve any parameter c. If I write the solution of this differential equation properly, which involves one parameter family of solution, it is in fact x square, नहीं यहाँ पे x4 ही है, 4 ही है, sorry, x यहाँ पे 4 है, ठीक है। So x square by 4 plus c whole power 2. This is what? This is a one parameter family of solution. Okay. It is also called general solution of the differential equation. Okay. A solution which is basically a one parameter or two parameter or three parameter family of solutions of the differential equations, they are called general solution as well. Okay. So this is the general solution. Let us include this thing first, general solution. Okay. The n parameter family of solution of a nth order differential equation is called general solution. ठीक है, अगर first order differential equation है तो one parameter family of solution उसका क्या होगा, it will be a general solution of this the given differential equation, general solution. Okay. Now if we insert any particular value of c in this general solution, we obtain a particular solution of that differential equation. Particular solution which doesn't involve any parameter. Okay. अगर आपके पास फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन है तो उसका जो जनरल सॉल्यूशन होगा वो वन पैरामीटर फैमिली ऑफ सॉल्यूशन होगा। अब इसके कितने पर्टिकुलर सॉल्यूशंस हम लिख सकते हैं? Anyone? If we vary the value of c, ठीक है,
इन्फिनिटी हो जाएगा।
c की कितनी वैल्यूज हो सकती हैं? इन्फिनिट मैनी वैल्यूज हो सकती हैं, तो इन्फिनिट मैनी पर्टिकुलर सॉल्यूशंस हैं, ठीक है। बट देयर इज ओनली वन सॉल्यूशन व्हिच सेटिस्फाई this initial condition according to that physical phenomena. In that case, we'll get only one particular solution which satisfies this initial condition. And that particular solution, in that solution which satisfies the initial condition, we obtain a solution without the parameters, and that kind of solution is called a particular solution of that differential equation. Okay. For example, इसमें c की क्या वैल्यू हमने पुट की? c की वैल्यू, फॉर एग्जाम्पल चलें आपके पास अगर आफ्टर सॉल्विंग दिस if we obtain this thing, now if I apply the initial condition y of 0 is equal to 0, तो c की वैल्यू यहां से क्या निकलेगी? If we apply this initial condition on this one parameter family of solution, what do you get? c
0.
0. So if we apply this initial condition, we obtain c is equal to 0. In that case, what do we obtain? This solution. And this is the solution, we call it a particular solution of this differential equation. A particular solution is a solution which can be obtained from the general solution by inserting some particular value of c. So this is your particular solution, okay? And what is the singular solution? Singular solution of a solution is the solution of a differential equation which cannot be obtained from the general solution. Okay. An example of that thing maybe I haven't written here some example. Let me see some example from here. Nothing. Okay, I'll give you an example of this thing. I'm not sure some example in my mind. Okay, it's not coming. I'll tell you later on. In general, a singular solution is a solution which cannot be obtained from the general solution by taking some particular value of C. Okay, that is a different kind of solution. Maybe, for example, maybe ज़हन में आ रही है, but I'm afraid I'll write it incorrect, but I'll tell you in the next lecture. Some example of the यहाँ पे भी नहीं है, नहीं है. चले. Give me a minute.
Excuse me, sir. Can I ask a question?
जी बेटा.
सर ये जो आपने स्टेटमेंट लिखी है y is equal to x square over 4 plus c का whole square, ये आपने कैसे लिखी है?
After solving this thing, after integrating this thing, I obtain here this function. And still we haven't discussed how to solve differential equations. ठीक है, अभी हम आगे चल के कुछ methods देखेंगे कि कैसे कौन-कौन से method हम apply कर सकते हैं in order to solve differential equation, first order differential equation, and then we'll discuss method for solving second order differential equations. Okay, you don't worry about this function. Where do we get this function? So we get this function after solving this. Okay.
सर एक क्वेश्चन था.
जी बोलें.
सर आपने इनिशियल कंडीशन यहाँ पर जिस तरह लिखी है y of 0 is equals to 0, तो इनिशियल कंडीशन क्या हमेशा 0 की ही होती है या फिर जैसे y of 2 is equals to 4 इस तरह भी हो सकती है इनिशियल कंडीशन?
It depends. मतलब अगर हमने एक डिफरेंशियल इक्वेशन डिराइव की है, मे बी there are more physical models which we will discuss in the upcoming lectures. For example, pandemic spread है, corona spread है, ये मेरे lectures पढ़े हुए हैं उसके IDE के. You can see in that one of that lecture modeling pandemic diseases. उसके लिए हम differential equation derive करते हैं. We get first order differential equation. But in that model, we assume that there are some initial number of infected people. मतलब हम कहते हैं कि अगर लम्स में अगर कोरोना अल्लाह ना करे फैलना शुरू हो जाए, तो उस मॉडल को जब हम डिराइव करेंगे डिफरेंशियल इक्वेशन, तो इनिशियल कंडीशन में कम से कम हमने रखना है कि जब मतलब फलां टाइम पे एक स्टूडेंट आया जो इन्फेक्टेड था, उसने फिर शुरू कर दिया. Normally initial conditions, that is why we call it initial conditions. They are normally defined at time is equal to 0. We assume that time t is equal to 0 in that model when that pandemic or जो भी है COVID वो spread होना शुरू हुआ. If we are not sure, or we are even if we are sure, we can take some other time. It is not always necessary or it is not mandatory that we take initial condition at time is equal to 0. Okay? It depends on your physical model. What is your model? It depends on that. Okay?
Okay, sir. Thank you.
सर इस तरह हो सकता है कि वो उन्होंने सिर्फ एक चीज दी हो, जैसे y इक्वल टू 0 और दूसरा उन्होंने ना दिया हो.
क्या मतलब?
सर जिस तरह यहाँ आपने दिया हुआ ना कि टाइम 0 0 है, तो अगर सिर्फ एक को दे दें तो फिर आई थिंक सिंगुलर
अगर
सॉल्यूशन
सिर्फ
शायद
y is equal to 0 कह देंगे ये इनिशियल कंडीशन है, y is equal to 0, तो it obviously means कि x 0 पे y 0 है. ठीक है? If they are not explicitly specified, the initial condition means the independent variable at 0, it should be y is equal to 0. So y of x is equal to 0 at x is equal to 0. There are different basically notations in order to define initial conditions. We can say it is at x is equal to 0 is 0. We can simply define it in this way, y of 0 is equal to 0. We can say that y at x is equal to 0 is equal to 0. So there are different notations for defining initial conditions. The initial condition can only is not necessary that it is only for the y. It can be on the y dash as well. Y dash of 0 is equal to 0. In the second order differential equations, you need two initial conditions. The first condition is on the y and the second condition is on y dash. Physically, what are you speaking? Basically, if you have a second order differential equation which describes some physical phenomena or some moving thing, because differential equations, they always they involve rate of change. Okay, so the things are changing in it. Wherever you find some physical phenomena in which rates of change are involved, then we can define the differential equation. For example, a car is moving, an aeroplane is moving, you are moving, air is moving, or water is moving. Differential equations can model only things which are moving or some kind of rate of change is happening in that phenomena. So if the thing is moving, or a second order differential equation is describing some body or some car is moving, then there must be two initial conditions. Where does that car started from? That will be your initial condition, the initial displacement. And second condition, which is more appropriate, what is the velocity of that car at time equal to 0? And the velocity of any function or any displacement function is what? It is the derivative of that displacement function. So if you assume that y describes the motion of a car, and it is basically modeled using second order differential equation, then y will be the displacement and y dash will be the velocity of that car at times equal to 0. So I hope you get it. So the initial conditions are basically, they are derived in a way, let me define it properly, the initial value problems. If we have an initial value problem of first order, okay, or you can say nth order, okay, it will involve f of x, y dash, so on, y nth dash. Okay, so you need to have n initial conditions, y at maybe x equal to 0, or y of 0 is equal to some constant alpha 1, y dash at 0 is equal to some constant alpha 2, and so on. You need initial conditions until the order n minus 1. Okay, so y n minus 1th derivative at 0 is some constant y alpha, maybe n. Okay, so this is basically the general nth order initial value problem. Nth order initial value problem. I hope you get it. If you have any question, you can ask me. Next time we are going to discuss the methods for solving first order differential equations.
Sir, can we leave class का time over हो चुका है?
Yes, you can leave now
Okay.
if you don't have any
अगर
question.
तो अगर हमारे
जी, जी।
पास सेकंड ऑर्डर डिफरेंशियल इक्वेशन हो और उसके बाद हमारे पास एक इनिशियल कंडीशन हो, तो हम कह सकते हैं कि उसका सॉल्यूशन सिंगुलर है.
एक initial condition नहीं है. You must require, yeah, you require two initial conditions in order to solve that physical model completely or differential equation completely. ठीक है? That would be an incomplete physical model if you have only one initial condition for the second order differential equation. In that case, you cannot have a particular solution which is required solution for that physical phenomena. You will have infinite many solutions, but because the solution will involve infinite many, the solution will involve parameter, and by changing the value of that parameter, you will have infinite many solutions. You don't need infinite many solutions. You need a particular specific solution according to your physical phenomena, which satisfy that the conditions of that physical phenomena. Okay.
जी सर.
I hope you get it.
Yes sir. Thank you.
Any other question? Okay, if you don't have any question, I'm gonna end this meeting for today. See you next time, inshallah.